Everyone's favourite, BOD. Okay, it's just one of those names that you go, BOD, what's that? Well, it's biological oxygen demand. So in this video for HSC chemistry water testing, we're going to be looking at what BOD is. And BOD is just simply an indirect way to measure the amount of organic matter from sewage or human effluent, etc., which is the same thing, sewage, human effluent, by measuring the dissolved oxygen. Okay, so it's an indicator. So BOD is an indirect, let's do it. Okay, so BOD measures the amount of sewage or the amount of waste. So if you're testing the water sample and you measure BOD, it might be near agricultural lands, and so there's a lot of cow waste that's running into the water. That's going to affect the degree of dissolved oxygen, and it's going to cause the production of possibly E. coli, etc., which is a bacteria that is pathogenic, and it's really something of concern. So BOD is related to dissolved oxygen. Okay, so BOD, the amount of biological oxygen demand. Well, what does that mean? Well, if you have a water sample and that water sample has microorganisms in it, those microorganisms want to respire. And to respire, you need a food source. So if there is organic material from human sewage that's in that water body, those microorganisms will use that as a food source to respire. And so therefore, you will find that the dissolved oxygen content will go down. Okay, so if you measure the dissolved oxygen at day 0 as a certain value, let's just pick anything, right? Let's just say you've got 10 parts per million, right? But then what you do is you get your sample, you seal it, you cover it and put it in the dark, and you leave it for 5 days, and then you measure the dissolved oxygen again. Let's say the dissolved oxygen has gone down to 5 parts per million. The only way that that dissolved oxygen can go down is if there is microorganisms present in the water using the organic matter as a food source, and that they respire. Because remember, respiration is when you are using oxygen to break down a sugar to make energy, right? So if they're using this organic material to make energy and therefore they're using up oxygen, it's going to go down. So BOD is just the difference in those two amounts. So it's the dissolved oxygen at day 5, take away the dissolved oxygen at day 0. Okay, actually, it's the other way around, right? It should be day 0 minus day 5, otherwise you're going to get a negative number. So let's just rub that out. All right. So it's dissolved oxygen. Oh, I like the pink. Dissolved oxygen at day 5, take away the dissolved oxygen at day 0. Right? Do 5 minus do. Sorry, I've been making videos for a while. It's getting into my head. So it's the difference in the dissolved oxygen. So if you have an unhealthy one, like let's say here, the difference in dissolved oxygen is 5 parts per million. So it's gone from 10 parts per million to 5 parts per million. If you have a healthy water sample, right, where there's no microorganisms in there, then you might find that your dissolved oxygen at day 0 was 10 parts per million, and dissolved oxygen up to 5 parts per million might not have changed at all. Let's say it's gone to like, let's say 9.8, because you might have had some oxygen just being lost, right, into the space up the top there. There's no microorganisms present. Maybe in the time that you've taken the sample out and tried to test it, you get slight amount of loss there. So in other words, the change in dissolved oxygen, right, that is BOD, is 0.2. So the smaller the BOD, the better. The higher the BOD, we have a problem, Houston. Okay, so that's what BOD is. And so if you were to look at values now at fresh water, so we're getting pretty close to the end here. I think in the next video we're going to try and find some questions where we look at all of these aspects. pH, dissolved oxygen, BOD, total dissolved solids. What else did we do? We did total suspended solids, All of those, we're going to look at how we can analyse a water sample and come to some conclusions about what possible sources of pollution there might be. All right, see you in the next video.